Okay, so today we're going to be covering lesson 10-4 on inscribed angles. So yesterday we covered lesson 10-3. We can cross that out. And then we're going to start by looking at the theorems for this lesson. So let's go to the bottom of our theorem cheat sheet here. It says the first theorem we're going to look at is a measure of an inscribed angle theorem. What this theorem states is that when you have an inscribed angle, notice how this angle goes all the way across the circle here. This angle measure is half that of the degree measure of the arc. So for example, if this measure is 60 degrees, then the arc would be 120 degrees. It's double the degree measure of the inscribed angle. Okay, so the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, and then we're going to move on down to the next one. Okay, congruent inscribed angles theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So here it may look like there's two triangles here, and there are, but what we're really looking at is the angles. There is an angle right here, and its intercepted arc is this right here. And then there is another angle right here with the same intercepted arc. When that happens, the angle measures are exactly the same. So this angle measure is the same measure as this one here. And then move on to the back. Okay, for this theorem, we're going to fill in the blanks first. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. That was a lot, right? Let's look at the picture. So here it shows that this line right here is a diameter, and then there is an angle right here. So it creates a triangle, and specifically when this happens, it creates a right triangle. So this diameter is a hypotenuse, and then this is a 90-degree angle here. And let's look at the last theorem, inscribed quadrilateral theorem. Notice that there is a quadrilateral inscribed in this shape. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. That means that they add to 180 degrees. So the opposite angles are supplementary. So that means that angle E and angle G would equal 180 degrees if you added them together. Or angle D and angle F are supplementary. So angle D plus angle F equals 180 degrees. Okay, so that is all the theorems that we need to know for the lesson. So we're going to move over to Workbook 10-4. So just flip over to the workbook page for this lesson on inscribed angles. Okay, and number 1, it asks for the measure of arc XY. This inscribed angle is half the measure of this arc, so we can do 23 times 2 to get 46 degrees. And that is our answer. Number 2, now they give you the arc measurement, and we need to find the angle measurement. So this is double that angle measurement, so we can do 162 divided by 2 to get 81 degrees. Number 3, they want to know the angle measure of angle R, which is right here. They do not give us this arc measure right here. We have to figure it out. We're going to take 360, subtract 120, and subtract 140 to get 100 degrees. So that is the arc measure here. This angle is half of that, so 100 divided by 2 is 50. So we get 50 degrees for angle R. And number 4. This one asks for the measure of arc MP. So that's this arc right here. I noticed they give me this angle. If I double that angle, I would get the arc measure right here. So this is 62 degrees. I also noticed that this line goes through the center, so it must be a diameter, and these two arc measures must equal 180. So I can do 180 degrees minus 62, and I get 118 degrees. And that's the answer to this arc measure. Okay, and they gave us some examples down here. We're actually going to do the examples on the back side, so you can cross these out. And we're going to go to the back of the page now. Okay, so these were pretty simple. You may get some of them on your homework, but I think you can figure them out on your own. These here, we're going to do an example for each type of problem, starting with number 5. So for 5 and 6, they give us this drawing here. These are the two inscribed angles, so there is an angle here and another angle right here, and they have the same intercepted arc. So that means that this angle is the same measure as this one. And if you look at it in the other direction, we have an intercepted or angle right here with the intercepted arc and an angle right here, meaning that this angle is the same measure as this one. Okay, then it asks for the measure of angle W. Measure of angle W would be the same as measure of angle X, and X is 22 degrees, so measure of angle W is 22 degrees as well. Then measure of angle Y. They gave us expressions for Z and Y, and we're going to set those equal to solve for X. So 3X minus 23 equals 2X plus 2. And now I'm just solving for X. I get X equals 25. It doesn't ask for X though, it asks for the measure of angle Y. Measure of angle Y is 2x plus 2, so 2 times 25 plus 2 would give us 52 degrees. Okay. Number 7 is almost the exact same as this one. For number 7, this angle would be congruent to this one, and this angle is congruent to this one here. Measure of angle A, 4x minus 7 equals 2x plus 11. I have to solve for x first. If I were to solve this out, x would equal, I have my cheat sheet here. X equals 9. And then to solve for a, we can plug that back into the expression. 4 times 9 minus 7, 36 minus 7 is 29 degrees. So measure of angle A is 29 degrees. Then measure of angle D. These two are equal here. 3y plus 8 equals 5y minus 14. If you solved for y, it comes out to y equals 11. And then to find measure of angle D, I have to take this expression and plug in 11. And it comes out to 41 degrees. So measure of angle D, 41 degrees. Okay, next example. This shows a diameter here and an inscribed angle that creates a triangle. When you have that inscribed angle with the hypotenuse as a diameter, this creates a right triangle, and that's going to help us solve this problem. So if this is a 90-degree angle and the three angles of a triangle add to 180, then these two must add to 90, and that's how we're going to figure this out. 3x plus 6 plus this angle x equals 90. Solving for x now. I get x equals 21. Well, that's great because I know that measure of angle C equals x, so this must be 21 degrees. And then for angle A, I'm going to plug in 21 into that expression. And I get 69 degrees for angle A. $69. Okay, moving on to the next example. Now we have a quadrilateral here. With a quadrilateral, the opposite angles are supplementary. So that means angle G and E would add to 180, and I'm going to set that up. 11x plus 8 plus 8x plus 1 equals 180. 19x plus 9 equals 180. Solving this out, I would get x equals 9. And then from here, to find the measure of angle G, I do need to plug that into the equation. 72 plus 1 would be 73 degrees for measure of angle G. And next is measure of angle H. Again, these two opposite angles are supplementary. 6y minus 4 plus 5y minus 3 equals 180. 11y minus 7, y equals 17 if we were to solve this out. And then the last step here is to plug it back into the expression for h. 6 times 17 minus 4. And 6 times 17 is 102 minus 4, 98 degrees. And that is our answer for measure of angle H. The last one, just cross it out. It is not included on the homework, so you don't need to worry about that. So right now you need to go and complete homework 10-4 on Schoology. And then if you finish that early, you can work on your Khan Academy assignments for the week if you have not already completed them. Okay, and that is all. I will see you tomorrow.